today we're going to be looking at regular polygons. And the first thing you need to know with a regular polygon is that you're working with a polygon with equal sides and equal angles. So in this section, we are working with regular polygons, which are polygons with equal sides and equal angles. Now, every regular polygon can be inscribed in a circle, which is what you see with all of these that I have up here, is we have regular polygons with vertices on the circle. That helps us understand some of these other definitions that we're going to work with. So the center of a regular polygon then is the center of the circle that would be inscribed in. That's our next piece of vocabulary here. Center of a regular polygon, the center of the circle that could circumscribe the regular polygon. Now we also have a radius of the regular polygon. The radius is the distance from that center to one of the vertices. That radius is also the radius of the circle that would circumscribe that polygon. The center of the regular polygon is the center of the circle that could circumscribe that regular polygon. And the radius, which is the next definition of the regular polygon, is the line segment that goes from the center of that circle to a vertex. So from the center of your regular polygon to a vertex is the radius of that polygon. The third definition under regular polygon is the apothem. The apothem, A-P-O-T-H-E-M. The apothem of the regular polygon is a segment that is drawn from the center perpendicular to the opposite side. So it goes from the center to the midpoint of the opposite side. These are always isosceles triangles. The perpendicular is going to be the angle bisector and the perpendicular bisector of that side. Now, if you want to find where are these definitions, because I see you're having a hard time seeing the board. If you look at page 441, we have all of these definitions on page 441. You're welcome. It is the line segment that goes from the center perpendicular to the opposite side here, or the side of the hexagon at its midpoint. It always goes perpendicular to that side of the hexagon at its midpoint. You're okay. Now, because these are regular polygons, the angle formed by two consecutive radii, so this angle right here, formed by two consecutive radii, is going to be equal to that angle and this angle. All of these angles formed by two consecutive radii are going to be equal. That angle is called a central angle of the polygon. So our third definition here under regular polygon is a central angle of the polygon. And what that is the angle that's formed by two consecutive radii. So we could be interested in what is the central angle of this hexagon. How can we find the central angle? Well, we know that a full circle is how many degrees? 360 degrees. And then this has 6 sides, so we're going to be taking that 360 degrees divided by 6. When we do that, we end up with 60 degrees, which means that these central angles are each 60 degrees. So when you draw the apothem in there, you are going to be bisecting that 60-degree angle, which means you're going to be forming a 30-degree angle. So this triangle is split into two 30, 60, 90 triangles. That means whenever you're working with a hexagon, you're going to be working with 30, 60, 90 triangles. Well, the other ones that give us special triangles are going to be the square and, let me try to get this so it moves, the square and the equilateral triangle. Those are the other ones that are going to give us special triangles. Here is why. In the square, I can get that to do what I want it to do. Think about 2 consecutive radii. That's your central angle. And how many central angles are there going to be? 1, 2, 3, 4, right? So we take 360 divided by 4.
Got it.
Yeah, it does. And we end up with 90 degrees. So in a square, the 2 consecutive radii form a 90-degree angle. Which means when you put that apothem in, you're going to be splitting that 90 into 45 and 45, which means you have, if you look at one of those triangles, you have a 45, 45, 90 triangle. The other one is this equilateral triangle. If you look at consecutive radii, that splits your 360 into 3 pieces. So when you go 360 divided by 3, you get 120. Since each of these angles is 120, when you draw the apothem in, it's going to split that into 2 equal pieces of 60. Which means you have a 30, 60, 90 triangle if you look at one of those. Okay, so we are going to be working with our special triangles a lot here. Now, our theorem is, how do we find the area of these polygons? So I'm going to grab another piece of paper that I haven't scribbled on that has these same polygons on it. And what I have here, let's fix this, lock in place. There we go. What I have here in this hexagon is several triangles that look just like this one. Okay, so it's not going to do that. Let me try again. Unlock. We have to send it to the back first. So order, send to the back. Now let's lock it in place. Locking, lock in place. Now I think I can do what I want to do. There we are. What we can see is this hexagon is made of congruent triangles. How many congruent triangles? 6 congruent triangles. So if I can find the area of this one triangle by looking at the apothem, The apothem we use the letter A to represent. Okay? And the side length we use the letter S to represent. Then the area of this one triangle, area of a triangle, is going to be 1/2 its base times its height, so 1/2 S times A. Try to put an A in there. And this, by the way, that we're starting to look at is Theorem 11.6. We're going to do the proof of it before we state it. Okay? So if you're thinking you don't need to pay attention right now, Dustin, what we are doing is the proof of Theorem 11.6. Okay? I'm going to do the proof before I state it. Yes, Branson.
Could you do the 360 divided by 6 too?
Yeah, that tells me that this angle right here is 60 degrees. That's what 360 divided by 6 is because here what I see is I have 6 congruent angles. They add to 360, so I go 360 divided by 6 and I got 60.
Okay, so you can figure it out like that.
Yeah, but the area of the triangle is 1/2 of its base times its height. Right? Now, the base of this triangle is the side length of the hexagon, which we call S. The height of the triangle is this distance, which is called the apothem, from the center perpendicular to that base. Okay? Now, so the area of one triangle is 1/2 S times A. Now, how many triangles are there? 6 we decided, which is the number of sides here. Yes, it is. Yep. So we then take, for the area of the polygon, with n sides, we have to take n times the area of your triangle. You guys need me to pay attention. So we have the area of one triangle, and there are n sides, so there's going to be n triangles. So we have n times the 1/2 S A. N times the area of one triangle. S is the side length. Because the area of the triangle, exactly, is the base, 1/2 base times height, and our base is the side length and the height is the apothem. So then we have n sides. This would be for a hexagon, there'd be 6 sides, but no matter what figure we're working with, we can always think of it as being made of however many congruent triangles, right? So how many congruent triangles are there? The number of sides is how many congruent triangles there are. So what we can do is take the area of one triangle, which base is S, which is the side length, height is A, which is the apothem, and the area of one triangle is going to be 1/2 base times height, 1/2 S times A. And then take with n sides, here we have n sides. When we take the area of one triangle times the number of sides, because that's how many triangles there are. And that gives us the area of the polygon. And we can do this with every polygon. We recognize that with every polygon, what we have here is in fact however many congruent triangles as we have congruent sides. What's that? I tried. Okay. I'm sure I won't succeed every time. So now, what we can do for every polygon then is find the area of this one triangle times the number of sides. Now, here's another shortcut to this. When we take and look at this formula a little bit, we can see that since it's all multiplication, it can be rearranged. That means I could put the 1/2 first, then the N, then the S, and then the A. And if you focus on N times S, that might suggest something else to you. Again, because it's multiplication, it doesn't matter what order you multiply in. So what I did is I just changed the order, put the 1/2, then the N, then the S, then the A. What is N, which is the number of sides, times S, which is the side length? It's the perimeter. N times S is the number of sides times the side length. And that's your perimeter, isn't it? So if we know that this side length is 6, you might say, well, let's make it 8 so it doesn't look like the number of sides. We know that this side length is 8, and we know that there are 6 sides, then our perimeter is going to be 6 times 8. Right? Because 6 sides, 8. Okay. So what we can do then is in this formula, we can substitute N times S for perimeter. Because perimeter equals number of sides times the side length. In our formula then, the area of a polygon one-half the perimeter times the apothem. I'm having a hard time making my A's not have a huge tail up there. There, I did it. This is theorem 11.6. Let's state the theorem now that we have used the paper. Theorem 11.6 says the area of a regular polygon is 1/2 the product of the perimeter and the apothem. No, it's either not happy or else very happy. Whichever. Okay. And we've already done the proof of it. We've already thought about why here. So, the area of a regular polygon, how do we find the area of a regular polygon, Dustin?
1/2 times 1/2 the side.
1/2 the side times A is the area of one of these triangles. But the whole polygon, what is it?
That's one area of one.
That's one of these triangles right here, is what that is.
Oh.
Right?
Number of sides.
Then you take that times the number of sides, yes. Now let's do a shortcut. You ready for a shortcut? The shortcut is, if you take the number of sides times the side length, you get the perimeter. So if you have number of sides times 1/2 the side length times the apothem, and you rearrange this, that means 1/2 the perimeter times the apothem. So the area of a polygon is 1/2 the perimeter times the apothem. Does that make sense?
Yeah.
Okay. So yes, you can take 1/2 the side length times the apothem and then times the number of sides. Or you can take 1/2 the perimeter times the apothem.
Is that pro?
Okay.